Okay, welcome to section P.1, Algebraic Expressions, Mathematical Models, and Real Numbers. If a letter is used to represent various numbers, it is called a variable. A combination of variables and numbers using the operations of addition, subtraction, multiplication, division, as well as powers or roots is called an algebraic expression. Find the value of the expression for a given value of the variable. Later on we'll be talking about evaluating an expression, and sometimes students will not understand the directions on a test or in the homework, and when it says to evaluate an algebraic expression, notice how the word value inside that word. So you're going to put a value in and you get another value out. That's how I tell students to remember that. Okay. The expression b to the n power is called an exponential expression. The n in this case is your exponent, and the b is your base. We'll talk more about that later. Okay, let's go to example 1. And example 1 is to evaluate an algebraic expression. So again, we're going to put a value in for the variable, and we're going to value back out for the expression. So here I have 9 plus 7 times x, the quantity x minus 4 to the second power, and we're going to let x equal 13. Let's rewrite this expression, and whenever we see x, we're going to put the value 13 in. So I now have that expression. Now we got to remember a little bit of pre-algebra, and we got to remember our order of operations. So you might remember something called "Please excuse my dear Aunt Sally," and you're going to do all the operations inside the parentheses. E is the exponential expressions. So if you have any exponential expressions, you're going to do those. Now, M and D stand for multiplication and division, and a lot of times students think that multiplication always comes before addition, and that is not the case. It is multiplication and division. You can do your multiplication and division from left to right. So if you have a problem like 10 divided by 5 times 2, you'd actually do this first because you see multiplication and division, but division is on the left hand side. So you can do that first, and then you do the multiplication second. So keep that in mind. And the last step is addition and subtraction from left to right. Okay. Multiplication always comes before addition. Division always comes before addition. But if you see multiplication and division, you can do left to right. For the addition and subtraction, do left to right. Okay. So this problem, I see parentheses, and I can do an operation inside this. I'm going to do that first. So I get 9 plus 7 times 9 squared. So 13 minus 4 is 9. Then I see an exponential expression, which is this right here. So 9 to the second power is really 9 times 9, so I get 9 plus 7 times 81. And you might say I have parentheses there, but you do have parentheses, but there's nothing you can do inside the parentheses. It's just 81 inside there. So now I have to look at multiplication and division. I see addition right here, and I see multiplication right there. So again, multiplication will always come before addition. So I'm going to do 7 times 81, which gives me 567. And I have the 9 plus that. And I'm going to go ahead and write that a little bit better. It looks kind of weird. 9 plus 567. So my answer is going to be 576. So notice how I put a value of 13 in, and my expression now has the value of 576. An equation is formed when an equal sign is placed between two algebraic expressions. Later on, or maybe on the test, a lot of my students will get an algebraic expression mixed up with just an equation. An equation is when you have two algebraic expressions and there's an equal sign in the middle. So this would be an equation. Here's an algebraic expression. Here's another algebraic expression and an equal sign in the middle. That's an equation. If I just have this, that's an algebraic expression. That's not an equation. You don't solve that. You would solve the equation. Okay, so we'll do that later on. So please look at what you have on a test, and if it says equation, solve the equation, there should be an equal sign already given to you. If it says to evaluate an expression, which we had this variable is called mathematical modeling. Such formulas together with the meaning assigned to the variables are called mathematical models. And we will see mathematical models and formulas throughout the course, so just keep that in mind. Okay. I really like example 2 because this is a math. The formula T equals 4x squared plus 341x plus 3,194 models the average cost of tuition and fees, represented by T, for public U.S. colleges for the school year ending X years after 2000. College for the school year ending in 2015. And depending on when you're taking this course and when you're watching this video, 2015 might be next year or it might have already passed, but we're going to assume it's in the future. So in 2015. So the year ending in 2015 is going to be actually 15 years after 2000. So X would represent, or X would have to have the value of 15. So now we're going to go ahead back to that formula, and we're going to go ahead and put the value of 15 in for X. And then we're going to now evaluate. We're going to go ahead and follow the order of operations, and I'm going to do them one step at a time. I'm going to do, they're inside the parentheses, there's nothing I can do. 15, 15, there's nothing inside there I can do operation-wise. So I'm going to go ahead and do the exponential expression. So just do one operation at a time because you might make a mistake, and I hate to make. So I have 900 plus 5,115 plus 3,194. And I get the value of $9,209. So this really means that in tuition and fees is projected to be $9,209 at public U.S. colleges. And again, this is not saying that U of L is going to be this price or UK, it's just on average, or so it could be a little bit more at U of L, it could be actually a little less, but around $9,209. Okay, so now 2000, what would the average tuition and fees be for the school year ending in 2045? And I forgot the word average tuition and fees, I have to write that in there. But you're getting the idea. So we're going to use the same model. And now for the years ending in 2045, how many years is that after the year 2000? Well, X would have to equal 45. That's 45 years after 2000. So T would equal 4 times 45 squared plus 341 times 45 plus 3,194. For our calculator, and if you don't know where the exponent button is for the 2 or how to raise second power, please refer to your calculator manual, or you can email me and I can help you figure that out. Okay, 45 squared is 2,025. And that's going to be 4 times 2,025, which is 8,100. Plus 15,345 plus 3,194. Add all the numbers together. And you should get $26,639. Let's double check that. I'm going to do it one more time. Wow, so in the year 2045, the average tuition and fees for the school year ending in that year at U.S. public colleges is $26,639. Do you see the big difference between that and that? Okay, and that is about 30 years later. So this figure might be the figure your grandkids, your kids would see, and that's for a public U.S. college. So you can see the cost differential. So the moral of the story is it's cheaper to get your education now than it would be 30 years from now. I'm just joking. Okay, so now the next thing I'll talk about is the real number line. And the real number line is very useful in many aspects of math, but today we're going to talk about positive and negative numbers and comparing them. Because the real number line, later on we're going to talk about numbers that are not real, imaginary numbers, so we're going to refer back to this number line later. But looking at this number line, we have the number 0 in the middle, and everything to the right of it are the positive numbers, and everything to the left of 0 is going to be your negative numbers. It's really easy to compare positive numbers. So if I were to look at the number 8 and the number 3, you could see that 8 number is more when you're dealing with two negative numbers. So let's say you have negative 8 and negative 4. Which number is bigger? Well, the number that's closer to 0 is going to be bigger, or the number on the right-hand side is bigger. So let's go ahead and look at symbols, and we're going to look at something called inequality symbols. So with inequality symbols, we have the greater than symbol, the less than symbol, the greater than or equal to symbol, and the less than or equal to symbol. This one's greater than, less than, this one is greater than or equal to, this one is less than or equal to. These symbols always point to the smaller or the lesser of the two numbers. Open to the, so let's look at what we just looked at a second ago. So I was looking at the negative 8 and the negative 4. We said that negative 4 was the bigger number or the greater number. So I could say negative 4 is greater than negative 8. Notice how it is pointing to the smaller number, which is the negative 8, and opening to the larger number, which is the negative 4. You could also say negative 8 is less than 8, or 8 is greater than 3. And then when we use these symbols here, you could say 3 is greater than or equal to 3, or 3 is less than or equal to 3. Those are some cases we can use those. Okay. Now, again, if you're trying to put an inequality symbol in between two numbers, you want to make sure that the statement is true. You want to make sure that you have the inequality symbol open up to a larger number and always pointing to the smaller number. Okay. The next term we're going to talk about is something called the absolute value. And the absolute value of a real number, A, it's denoted with the two vertical bars, is the distance from 0 to A to the number line. Distance is always taking me non-negative, which is basically positive. So whenever you're measuring distance, you're always measuring it as a positive value or a positive number of units. So this right here, absolute value of negative 3, again, these vertical bars just mean the absolute value, and it's just asking me what distance is negative 3 to the value of 0. So here's negative 3. I'm going to marker here. How far is negative 3 to 0? It is 1, 2, 3 units away, so it's 3 units away. The next one says the absolute value of 3. Well, how far is 3 from 0? 1, 2, 3. It's 3 units away. So notice how the absolute value of negative 3 and the absolute value of 3, they're both just 3 units away from 0. 9, absolute value of 9 would just be 9, it's 9 away, and absolute value of 0, how far is 0 from 0? It's just 0. That's the only time when it's not a positive number. Okay? Remember, all absolute values, it's always going to be a positive value or 0. Okay. If you turn your book to page 12, there are a bunch of properties of real numbers that I tell students, I'm not concerned that you memorize the names of them. You might have to know the names when you do your homework, but I'm more concerned that you understand that there are certain properties of real numbers that always occur. And one of them is called the commutative property. And again, you don't have to memorize the name commutative, but I want you to understand that the commutative property is just order. So let's say I have the problem 3 plus 4. And I change the order around, I do 4 plus 3. Do you understand that that's the exact same value no matter what order I put that in? 3 plus 4, same thing, 4 plus 3. The order did not matter. Likewise, if I have 4 times 3 and then 3 times 4, I get 12 no matter what I do. 4 times 3 is 12, 3 times 4 is 12. So it doesn't really matter what order I put that multiplication problem in. So whenever you have addition and multiplication, order does not matter. So if you had 5 minus 7, that's not the same thing as 7 minus 5. You'd get negative 2 here and you'd get 2 here. So order does matter in subtraction and division. So just keep that in mind. So we'll look at later on, we'll do a problem, and I'll just switch the order of the addition problem. And you should understand that it doesn't matter. I've got to do that. Now page 12, it goes over that. And associative property says that grouping doesn't matter. So let's look at a problem, and I'm going to look at it 2 different ways. Let's say I have the problem 5 plus 3 plus 1. And I'm going to look at it in a different way. Let's say I have Kelly here. I'm going to have Bob here. Kelly says, well, you give me 5 plus 3 plus 1. And I'm going to go ahead and just do the 5 plus 3 first. I'm just going to go from left to right and do 5 plus 3 first. Well, 5 plus 3 is 8, and I'm going to add the 1 later, or she adds the 1 later, and she gets 9. Well, Bob says, well, I'm going to do something different. I'm going to go ahead and do the 3 plus 1 first, and by grouping, we usually use parentheses. So it didn't matter that Kelly decided to do the 5 plus first, and then add the 5 later. Grouping doesn't matter with addition. Same thing with multiplication. If I had 3 times 2 times 5, and then I had 3 times 2 times 5, and Kelly decided to do the 3 times 2 first, and Bob decided to do the 2 times 5 first. It doesn't really matter. Kelly would get the answer of 6 times 5, which is 30, and Bob would get 3 times 10, which is 30. So addition and multiplication, grouping doesn't matter. It does matter in other operations. So to keep that in mind, addition and multiplication, we can change the order and we can change the grouping of how we do the operation, and it would not matter. And you read through the other ones. There's the identity property of addition and so on. Those are the things that we'll look at throughout the semester. I'm not concerned about the name, just concerned that you understand how those work that way. There is one property that I do want you to know by name, and I will say it plenty of times this semester. You will hear it in probably every math class you take, and we use this a lot. Distributive property of multiplication over addition. And I just call that distributive property. Okay. Let me go over what the distributive property is, and then I'm going to show you why it works, and then we're going to look at when we use it. We don't use it all the time. Sometimes we don't have to use it. I'm going to erase this and give myself some more room. So, distributive property of multiplication over addition just basically says that we have a multiplication, which is right there, that parentheses indicates multiplication, and we have over addition, which is right there, the b plus c. What that means is I'm going to take the a times b, so I get a times b, and then I'm going to do the a times c, I'm going to do plus a times c. So I actually did the multiplication before I did the addition. Order of operation tells me I should have done the addition first, because that's the that parentheses. But I'm going to do multiplication over addition. And that's a distributive property there. Now some students ask me, well, why didn't I do and follow the order of operations? You can actually. Sometimes you can, sometimes you can't. So let's say I have the problem 3 times a quantity of 4 plus 2. And let's say I were to follow the order of operations. If I follow order of operation and ignore the distributive property, I would do this first, and I would get 3 times 6, and I would get 18. Right? But let's say I do distributive property. And I'm going to abbreviate that because I'm running out of room. That's 3 times 4 plus 2. Well, distributive property tells me I'm going to do the multiplication over addition. So I'm actually going to ignore the addition first. I'm going to do the multiplication first. So I get 3 times 4 plus 3 times 2. Well, 3 times 4 is 12. I put the plus on there, my bad, plus. So 3 times 4 plus 3 times 2. Plus 3 times 2, which is 6. I do get 18. I get 18 both cases. If it were just numbers I'm working with, then you probably just want to do this way. But what if I have something inside the parentheses right here and here, and you couldn't add them together? What if I had x plus 2? You can't add x plus 2. Then the distributive property becomes really important, and we'll see that in an example later on. So keep that in mind. Distributive property and order of operations, they both give you the same answer, but sometimes you can't do the order of operations because you can't add these two together. And we'll see an example in just a minute. So make sure you understand distributive property. And that's one that I will probably have on the test where I'll say, do the distributive property. Use the distributive property. And then you have to understand that you can do multiplication over addition. And then sometimes it's over subtraction, but it's basically the same operation. Okay, to simplify an algebraic expression, we combine like terms. An algebraic expression is simplified when parentheses have been removed and like terms have been combined. Here's the great example of when I cannot do the order of operations. Because I look at the order of operations and I try to add this to this and this to this. Well, you can't add 3x squared plus 4x because they're not like terms. They have different variable parts. One has an x squared on the variable part and one has just an x. So we can't add those together. This is when you say, well, I can't add those two inside the parentheses, but I can use the distributive property. And again, the distributive property is multiplication over addition. So I like to do this. I'm going to take 7 times 3x squared, which is 21x squared. And some people will write 7 times 3x squared. If you want to do that, you can, but I'm going to skip that step. And then you're going to do plus 7 times 4x, which is 28x. And notice how when you do the distributive property, those parentheses disappear. Okay, they disappeared up here. Okay, so make sure that you do not copy those parentheses. Then we're going to have plus 9 times 5x squared, which is 45x squared, plus 9 times 2x, which is 18x. So the distributive property helped me get rid of those parentheses. And again, it says an algebraic expression simplified when parentheses have been removed. I just removed them. And now it says like terms have been combined. Well, we do have like terms. Notice how the 21x squared, the x squared is like the 45xx is like the 18x. Okay. The 21 plus 45, when we add like term, we combine the coefficients, the numbers in front. So I get 66. And then I keep the variable part, I get x squared. And then 28x plus 18x gives me 46x, so plus 46x. I can't combine this and this because they both have different variable parts. So there's my answer right there. Notice how it's an algebraic expression. I'm not solving it. I'm just combining like terms. I'm not figuring out what x is because I have no idea what x is. That goes back to something I said earlier when I said remember the difference between an algebraic expression and then an equation. We'll talk about equations in chapter 1. Okay. So let's go ahead and if you need more practice, turn to page 14. And get a sheet of paper out and do checkpoint number 8. And I like the checkpoint because all the answers are in the back. So if you want to pause the video, go ahead and pause it. And then, and when you start the video back up, I'll give you the answer if you don't look it up. And the answer is 38x squared plus 23x. Okay. Hopefully you tried that one out. And I think it's really good for you to practice these examples on your own so you can be ready for your homework. Okay, example 9, simplifying an algebraic expression, and we have an algebraic expression with more than one set of parentheses, and inside the parentheses I can't combine those two, so you can't follow the order of operations. When you have more than one set of parentheses, you're going to deal with the innermost parentheses first, and I want you to look at this innermost right here. And so keep in mind, I tell students that whenever you see a set of parentheses, you want to get rid of them, and you're looking to do the distributive property, look at the number outside the parentheses. And I don't see a number outside there, but I can go ahead and put a 1 there. So I'm going to go ahead and drop down the 8x plus 2, drop down the bracket, drop down the 5, and I'm going to think of this 1 as a negative 1, put that minus sign with the 1, put the negative 1, and we'll multiply that across the parentheses right here. So negative 1 times x is negative 1x, and the same thing as minus 1x. Some people will not put that 1 there. They'll know it's there anyway. Okay? And then we take the negative 1 times, and I'm thinking of the negative 3. So it's going to be plus 3. Now inside that bracket, I actually have like terms. The 5 and the 3 are like. So I'm going to go ahead and combine those. I get 8x plus 2. Bracket, and I have 8. They came from the 5 plus 3. And then I'm going to do the minus x there. And now inside that bracket, there's nothing I can do inside there. Now I'm going to go ahead and do the stir proper again. And brackets are the same thing as parentheses. They have the same idea. So I can take 2 times this and 2 times that. I'm going to drop down the 8x, and I get plus 2 times 8, which is 16, minus 2 times the negative x, which is minus 2x or negative 2x. I have like terms. So I get 6x plus 16. And if you write 16 plus 6x, that's the same answer. Okay? So either one's fine. Now if you want to go ahead and do checkpoint number 9 on page 15, go ahead and pause the video. And I'll give you the answer in just a second. Ooh, I spelled video wrong. Okay, video. Go ahead and pause it. Okay, and hopefully you play the video again. The answer is 42 minus 4x. Answers. Okay, that's the end of section P1, and I'll go ahead and stop the recording, and we'll work on the next section in just a minute.